In this video, we'll talk about systems of linear equations, what they are and how to solve them. As we discussed in a previous clip, a linear equation is just something that has one or two variables in it of power one. And a system of linear equations is just when you have a collection of these equations that contribute to one graph or function or idea. So the method to solving them is through substitution and elimination. The rule of thumb here for linear equations is that you have to have as many equations as there are unknowns, like as there are variables. So if I had an equation that had x and y, then I would expect to have another equation of x and y so that I have two equations to my two unknowns. That way I can solve for one of them, substitute, eliminate, and find my solution for both of them explicitly. So like an example of this being here would be like this is a system of linear equations because they're linear because these are all of to the power one. It's a good system because as you can see, I have x, y, and z, and then I have three equations here, which means I have three equations and three unknowns. Therefore, I could solve for each of those unknowns, x, y, and z, explicitly in this problem. So let's test ourselves by doing a few examples so that we can really hammer this method home. Here we have two equations and two unknowns, x and y. Therefore, I know I can solve for x and y explicitly here. If I solve for y, I can get y is equal to 3x minus 7. Now I can take my expression of y and plug it back into this second equation to get an expression for x. So now looking at the second equation, I have 2x plus 3 times y, but since I know y to be this thing up here, I say 3 times 3x minus 7 is equal to 1. Now I have 2x plus 9x minus 21 is equal to 1. So now I have, this is 11x is equal to 22. Therefore, x is equal to 2. Now that I know what x is explicitly, being 2, I can plug this back into my known equation for y and get y is equal to 3 times 2, which is 6, minus 7, which is equal to -1. We can test ourselves too by plugging them back into any one of these equations to see if it makes sense. So if I plug both x equals 2 and y equals -1 into the first equation, I will get 3 times 2, which is, well, actually, we already did it for the first equation, get y. So if I do the second equation, I'll get 2 times 2, which is 4, plus 3 times -1. So it's 4 minus 3, which ends up being 1. So this all makes sense. And we can check ourselves right now. Right, so we solve for y here, substitute y into the second equation so that we could get an explicit value for x. And then you're going to plug the x value back into the equation that we used for y to get y. Awesome. So then recap our solution again is x equals 2 and y equals -1. Okay, now let's try a different example that'll tell us something different about these types of problems. So if I solve for y again, I get y is equal to x minus 6 If I plug that into here, I get negative 2x plus 2 times x minus 6 is equal to 1. So I have negative 2x plus 2x minus 12 is equal to 1. So since we can see here that I have a negative 2x and a plus 2x, these two things cancel, and now I'm left with some sort of solution like negative 12 is equal to 1. And I sure hope that if you're looking at this, you'd be like, well, negative 12 is not equal to 1. So this can't be right. And you're looking at it, and you're like, well, what did we do wrong? Well, we didn't do anything wrong. We actually did everything correctly. This just proves to us that there actually is no solution to the system of linear equations because there's no numbers that can commute between the two. We can see this also right here, like in this example, they actually tried solving for x. So they have x is equal to 6 plus y. They plugged it in, and then they ended up with the same type of problem where negative 2y plus 2y just cancels out. And now they're left with some ridiculous statement like negative 12 is equal to 1. But since negative 12 obviously cannot equal 1, there are no solutions to this set of equations. All right. So the first example, we had solutions for our set of equations. The next example, we had no solutions for our set of equations. Let's see what this example is going to give us, if there's any other type of, set of solutions to these. So if I'm solving for x, I get x is equal to negative 1 minus 5y. If I plug that into the second equation, I get negative 5 times negative 1 minus 5y minus 25y is equal to 5. Simplifying, I get 5 plus 25y minus 25y is equal to 5. These things cancel out. And now I have a statement like 5 is equal to 5. So unlike the last example where when the things cancel it out, the statement was false, saying something like negative 12 is equal to 1. This statement's actually true. So we did our substitution correctly, but now our statement just has 5 is equal to 5. Okay, so what does that mean? Well, that means that no matter what value of x and y we substitute into this equation, you will always have the same answer pretty much. That means that this system of equations has infinitely many solutions to this problem. So that kind of that puts in perspective the different types of answers that you will get when doing systems of linear equations. I would say 9 times out of 10, you're just going to have something that works. So you would, go through the steps, solve one of the variables, plug it into the second equation, solve that variable, and then get the last one, the first variable explicitly. That almost always works. But I had to go over these two types of examples because there will be times when you'll be doing it correctly, and then you'll get some nonsensical statement like, 7 equals 90. And then you'll be like, okay, well, this doesn't make any sense. Well, that's because that system of linear equations has no solutions to it. And similarly, you might be going through the rigmarole and find that your solution ends up being just some statement like 1 equals 1 or 0 equals 0. And that, again, pretty much means that you didn't do anything wrong. That just means that no matter what the variables are, x or y, there are going to be infinitely many solutions to the system because it's just always going to be a true statement. So that about wraps up the intro to systems of linear equations.